All right, how's it going, everyone? Doing well? Not too enthusiastic. Okay. So, yeah, today we're going to be talking about web standards. This is my first time using a clicker, so bear with me here. The talk is called Hitchhikers Guide to Web Standards, and to kick things off, I'd like to introduce myself. My name is Dom Ferrellino. Yes, I'm named after the platform that we all know and love. I'm a senior at the University of Cincinnati in Ohio, and previously I've held internships at Microsoft and Mozilla, working on Firefox. And I'm going to be doing a final internship at Google in Japan, actually working on Chromium and the web platform. So currently I'm a Chromium committer, which is basically fancy speak for someone who has write access and can approve certain stuff. And I'm also a What Working Group standards editor. So if you don't know what that last one is, that's primarily what we're going to be talking about today. Aside from that, you can follow me on Twitter and check out my work on GitHub. And feel free to email me anytime, during or after the talk, dom@chromium.org, with any questions about getting involved in the web platform, web standards, and browser stuff in general. So I want to talk about what this talk actually is. I kind of had three overarching goals that I wanted to reach when working on this talk. And the first one is just provide a background and history into web standards and some of the organizations that are responsible for their governance and their authorship. This could really be in its own talk, but I know we didn't come here for a history lesson, so I'm just going to give a brief history on this to kind of set the stage. Next, I want to talk about, as a web developer, how can you actually make use of a web standard, right? A lot of us go to MDN or Google some API and figure out how it works, but I kind of want to talk about the technical bits of web standards and show how you can make use of them and how to read them and how to navigate that space. Finally, I want to talk about how you can get involved. I want to share a bit about my own story of getting involved with web standards and working on the web platform, and hopefully encourage some of you to do the same. So to kind of set the stage for the talk, I'd like to propose the idea that we need a definition of a standard. Now, largely, this depends on context if we're going to define a new word. And so I'd like to propose my own definition for the purposes of this talk. It's a little bit wordy, so bear with me. A document specifying observable effects of technology with multiple independent implementations. Now, it's kind of wordy, like I said, so let's just focus on some key points, right? We care about the observable effects of technology. What are the side effects of it? If I run something, what does it do? How does it look and feel? How can I actually use it? And does it change depending on where I'm using it from? And this last part is multiple independent implementations, technology with multiple independent implementations. I think this is really important, and it's far from a new concept in technology. We've seen this with like Unix operating systems, for example. I can kind of make my own version of my own Linux distribution. You can have your own Linux distribution, and you get one, and you get one, and everybody can have their own separate distribution with sugar on top of it. But what I really care about as a desktop app developer, if I were one, is can I write an application that works once everywhere, and no matter what operating system I'm using for that's in the Unix family of OSs, that it's going to work uniformly. So to kind of make that environment conducive to that interoperable behavior among the different operating systems, we've had these set of POSIX standards developed to kind of unify this observable behavior. The same thing goes for web tech, and this is primarily what I'm going to talk about today. These are not actually to scale, though. But I happen to know for a fact that you can't go to the store and buy one HTTP. It's a protocol. It's just an idea. And it's something that you can implement to kind of make it compatible with other versions of this protocol. And the same basically goes for JavaScript as well, right? We can run JavaScript in a bunch of different places, unlike maybe Python. It's kind of like we have one Python we get from the Python people, and that's kind of it. But with JavaScript, I can run it in Chrome, I can run it in Edge, on the Chakra engine, and I can run it in Node, and all kinds of different places. And the same goes for kind of the star of the talk today, which is the web platform APIs. So I've gone through a career change. I'm now no longer a Unix app developer, but I'm a web developer. And so I need to know that the same APIs that exist in Chrome also are going to be there in Firefox. And more importantly, that they're all going to work the same and kind of function uniformly. That's really important. Probably the biggest thing I learned when making this slide is, though, that Keynote is really cool and has a bunch of different goofy symbols that you can use. So I thought that little dude looked like a face, so I dressed him up, gave him some underwear and a hat and stuff like that. So let's talk about where web APIs come from, right? This is important. We are web developers, and we kind of want to know where this stuff comes from and how we can make more of them. I personally think the logical answer probably is JavaScript, right? We use web APIs when we're using JavaScript. For example, here's a snapshot of the Chrome Dev Tools, and when I'm I can write things like a for loop and a while loop, but I can also fetch super prominent websites on the internet like that one. And I can use set timeout and all kinds of stuff like that. So it stands to reason that this kind of stuff is part of the language. Now we have to talk about what is the language, or what is JavaScript. I'm just going to fly through this slide, because we all know the big story of Brendan Eich, and he created it in 10 days and whatever. But it's just a general purpose programming language that is created for the purposes of the web. It was plopped into Netscape 2.0. And that made it a really interesting thing. It made it a candidate for standardization because there was going to be multiple independent implementations of it. And so we needed some group that could come by and pick up the task of standardizing. And ECMA did this. They stand for the European Computer Manufacturers Association, and they created ECMAScript. And we've had some success with this, with the various engines. For example, there's a bunch of different implementations of the same sort of technology. You probably have seen this list or something similar to it before. The standard looks something like this. It's really big, it's really hard to read, but it's on GitHub, and it's hosted under the TC39's GitHub page. TC39 just stands for Technical Committee 39. So when we're writing the standard, we're writing ECMAScript, how does it work, right? What are we going to put in the standard? We're making a new language, so we have to make it really general. So we need a really strict separation of concerns between all the contents in the standard. We just need to be dealing with the language, syntax, and the semantics, and some of the constructs and the primitives. And as a true scripting language, it should be able to be plopped into any host environment. But the language itself shouldn't actually have to know anything explicit about that environment. Now, we're really used to using that language in the web browser, so we're used to web APIs and stuff like that. But the language itself doesn't actually know about those things. So web APIs are not part of the ECMAScript language or JavaScript language. They're effectively mix-ins. And they're baked into browsers, and browsers can support basically a version of ECMAScript as their JavaScript engine and a bunch of web APIs that we can use that kind of tag alongside this version of ECMAScript that kind of interplay with it. And so we have ECMA, right? They're responsible for, and TC39 are responsible for standardizing ECMAScript and JavaScript that we all know and love. So who's responsible for standardizing the web APIs? We've kind of heard a little bit about this today from some of the talks. There's two big groups right now that are responsible for this primarily. You've probably seen at least one of these logos before. We have the W3C and the What Working Group. And the What Working Group, denoted by the question mark on the right, is what I'm going to be talking about primarily today. This is the organization I told you all that I was a part of in the beginning. So the What Working Group it's just an acronym, unfortunately. So it stands for a long string of text that kind of summarizes what we do. It was formed in 2004 after a W3C workshop. Basically, they decided to kind of branch off from the W3C and create their own canonical standards that specify the web platform. So they have an HTML standard, which kind of defines the HTML language and the parser and the event loop, and a lot of it's basically the kitchen sink of the web platform is actually what it calls itself to. And they have, they specified the DOM APIs, the interface that we use to talk to the web, and some networking primitives like fetch and streams, and a lot of really cool things like notifications and primitives. But how are these things actually written, right? If we're going to write a browser and we want to write ECMAScript, we start with the JavaScript engine, okay? Now, if we read the ECMAScript spec, there's a lot of stuff in there, but there's also a bunch of exposed objects that we get for free in JavaScript. We get things like the array constructor and, date objects and weak maps and all kinds of data structures that are natively exposed through ECMAScript. But we want our browser to be a little more powerful. We want it to have me, the DOM. So we give it a document object. We can add a couple more paragraphs onto the end and give it a query selector method. And we've kind of extended our language a little bit more. The document's getting bigger, but it's getting more powerful. So we also would love to contact the network as well. So we'll give it some networking primitives, things like fetch, things like request. And it'd be really cool if we could do ourselves a good service and debug our code. So we'll maybe give it a console object as well, and a bunch of methods on top of that. This is one way to write it, just keep appending text onto the same massive document. But it's going to get pretty lengthy and unmaintainable. So the What Working Group maintains separate standards for each of these kind of ideas that have a separation of concerns. And each standard is responsible for talking about how they interleave with the other specifications in the web, as well as ECMAScript and things like that. And as a result, we get web APIs alongside ECMAScript and JavaScript. Now, if we want to read these web APIs, as web developers, we want to make use of them, we need to kind of know the anatomy of a standard. We need to know what is actually in these documents, because it's kind of a mystical thing and mystical process. And it's actually really not too difficult to get involved. And it's all very open and happening right under our noses. So I was thinking about this a lot for this talk, and I kind of came to the conclusion that there are two big parts of standards to kind of be aware of. The first is algorithms. So I don't know about you guys, I love algorithms. I spend many an evening, as it were, working on LeetCode code and HackerRank stuff, and I really like algorithms and data structure stuff. I think that kind of theory of computation is really, really cool. Algorithms are really just a set of steps to perform a task. So let's go ahead and take a look at an algorithm inside a web standard, right? We have the console standard, and there's a bunch of different methods on there. If you haven't heard of it, there's one called console.count. And here's the algorithm specified in the standard. There's 5 steps that run every time you invoke console.count. There's a couple that we really care about for the purposes of this talk, though. You can see we're given something called a label. And basically, the idea of this algorithm is if we've seen this label before when we've called this function, then increment some number that we have associated with label. Otherwise, we can set it to 1. This is the algorithm. And then eventually, we want to just print it to the screen. This logger thing is just abstract text for saying, hey, browser, show this to the user in whatever way you see fit. This is nice because as a web developer, I can come in here, check out the algorithm, and it answers a couple questions for me, like, what is the initial value of the number that is associated with a label? And what happens every time I call it? And what can I expect? And so we can read the algorithm and kind of understand what's going on. Now, the second important thing about specifying and using web APIs is understanding the look and the feel. So I think that's really important. What's it mean for an API to have a look and a feel? So I thought of this, and I think it's kind of like, what's it mean to use the API as a developer? What's it called? Where is it hanging off of some other object? Is it just globally exposed? Does it take anything? Is there a bunch of parameters? How many parameters? Does it return anything? This stuff is really important for us to know. And a lot of us are used to going to MDN and maybe Googling this kind of stuff to find it. But I also want to show that you can just go to the standard. So here's another part of the console standard that the working group maintains. It's a big, scary block of text. But let's focus on the bit that's complementary to what we were talking about before, the count method. So we have this, right? This kind of can tell you a little bit about it, right? OK, so it's called count. It exists under the console namespace, so console.count, that kind of makes sense how I would use it. It's of type void, so I probably shouldn't expect to get anything from it. It's just not going to really return anything, but it might do stuff. And it takes in a single parameter called label. It's optional, and its type is DOM string. So we don't know what DOM string is right now, but let's just assume it's just a regular string. That gives us some cool information. It's pretty expressive, but it's not JavaScript because we care about types. And it's not C++ because we see other invalid things going on around here. So what exactly is this language? It's called WebIDL, and it stands for Web Interface Definition Language. And you'll see it in a lot of specifications. And it kind of forms a contract for basically the signature of web APIs that you use. And that contract protects the algorithm. Because when I go into the algorithm and I'm running these steps, I want to be able to know what label is. I need to, maybe I'm making some assumptions that it's a string and I'm operating it on that accordingly. And that's really important for me to know. And so I want to talk about how WebIDL actually works in practice, okay? So you're a wily JS dev, you've got your Viking hat on, and you don't really care about types, right? So you're going to call, you're going to mash on your keyboard and call console.count. And you're going to just give it whatever you want. You can give it a symbol, right? You can give it an object, you can give it whatever. But the second you do that, the WebIDL sheriff is going to stick in, it's going to come in. And it's basically going to be like, hold up. You called console.count. And you can give it whatever you want, right? Symbol if you want it to be so inclined to do so. You can give it a number, whatever. But I'm going to make sure that this contract is obeyed. I'm expecting a DOM string, and I'm going to make sure that whatever you give me can pass as a DOM string. And if it does, that's cool. We can go to the algorithm, continue with a hopefully successful call, and keep going. But just like a sheriff can throw someone in jail, the WebIDL sheriff, so to speak, can throw a type error, resulting with you in code jail, which is probably the worst place to be, right? You're staring at the terminal, or sorry, the dev tools, and you got all this red, scary text around. You don't know what's going on. So we want to stay away from that. Now, real sheriffs in the real world know who to arrest, who not to arrest, stuff like that. That's really important. It's a big part of their job. So they kind of basically have a rule book of things to follow here. And just like the real sheriffs have a rule book, the WebIDL sheriff has a rule book in the form of the WebIDL standard. And it basically defines a lot of the stuff that it's supposed to be enforcing. So we saw an example of conversion. Here's a snippet from the WebIDL standard that basically is responsible for converting an ECMAScript value to what is called a DOM string, something that the WebIDL has defined. Basically, the meat of this algorithm is just to kind of delegate to step 2 and call this toString thing. This is an abstract operation defined in the ECMAScript standard. So we're just kind of passing through right to the ECMAScript spec. And we could, of course, write toString everywhere we needed to instead of using WebIDL. But yeah, this is really nice because it's pretty expressive. It tells us how things should work in a really normative, clear way. And it protects our algorithm. When I get to here, I can know that I'm working on a string and that things have been accepted and the sheriff is OK with it. So why are we using this thing called WebIDL anyways, right? What exactly is it? So it's just an abstraction over ECMAScript text. As you saw, step 2 was we just kind of delegate to the ECMAScript standards toString thing. It does a lot of things for us, though. It helps us write a lot with just a few words, potentially. It takes care of a lot of type conversions. We saw a really simple example of a type conversion, but you can imagine perhaps potentially a much more complicated one. And we wouldn't want to repeat all those steps to convert things and kind of make our assumptions everywhere we needed to in the spec. So we can use WebIDL to kind of just abstract that stuff away. It also takes care of things like property initialization for us and other stuff like that. It also helps us define where interfaces are exposed in a really expressive way, like we saw. But I think the most important thing about WebIDL, personally, is that you don't actually have to use it. It's, as line 1 suggests, just an abstraction over the ECMAScript text. And that's really important because we have some standards that are written without WebIDL. And that's totally valid. It just kind of speaks within the same language that the ECMAScript standard speaks in. It uses the same verbiage and the same sort of stuff. But WebIDL is just a nice way to be succinct and kind of foster interoperability on the platform. So you can always feel free to, hopefully that little foray into WebIDL makes you a little bit more comfortable reading some of the standards that they come within. So finally, I want to talk about how I got involved in this and how you can do the same and hopefully motivate you to do the same as well. So who knows this logo? Let's get a raised show of hands, right? Hey, a lot of people. Cool. So this is the Angular logo. This flat design, I believe, is new since Angular 2. And basically, a couple years ago, I was like, yeah, I'm going to start doing more stuff with web applications, so I better learn a big, heavy framework that can bog me down and figure out how to write all this stuff. And so Angular 2 at the time was an alpha. It was basically a mess, right? Things were always moving around, and I would always hear people say, yeah, Angular's getting a new router, or Angular's getting a new object, or this kind of stuff. And it was really easy to track the progress of this. It was happening on GitHub. I knew some of the people working on it, so you could always just kind of dig around. At the same time, I heard another camp of people kind of talking about JavaScript. They were saying, hey, JavaScript is getting, async iterators, or, do you know about custom elements? Can you figure out how to use those? And I was like, well, that's interesting, because that's not really Angular specific. So I was really interested in digging around, figuring out who's deciding this stuff, because how does this work? I kind of want to be a part of it. It seems pretty cool. We're evolving the platform. So I eventually came across this guy's profile. His name is Dominic Denicola, and I just learned recently that he was actually a speaker at the first Cascadia JS in 2012. It's true that we both have the same name. That's pretty cool. And so I reached out to him. I was like, hey, I see you're working on the what working groups standards and a lot of stuff like that. Big contributor to the TC39 proposals. And so I had reached out and I was like, hey, what do you do really? And how can I do it too? It seems kind of cool. Are you actually paid to work on this stuff? It's pretty cool. And so he was basically like, hey, we both have the same name. We're both DOMs, right, and working on the platform. So I'll let you in on some secrets. And the biggest piece of advice here was probably to dig around on some of the what working group standards and actually just take a look at some issues. There's a lot of issue labels that the issues are kind of affixed with. One of them is good first issue, and basically, as the name implies, they are good first issues for people to get involved in. And a lot of them are low-hanging fruit, or some of them are editorial in nature that you can just kind of go in and dig around in a web standard and figure out how to work with them. I want to cut away, though, from Keynote and probably screw a lot of things up in the process, but let's see if I can just show what the what working groups page looks like. Hey, do we have it? Yes, okay. Now if I could figure out where my mouse is, that would also be cool. 1 second. All right, cool. So here's the what working groups GitHub page, basically. Just to kind of show you, it's all open, it's all happening right in front of you, and it's a very welcoming area. You're allowed inside. Basically, this is basically just a list of all the specifications that we maintain. It's a giant list of the HTML standard, the fetch standard, and stuff like that. And so we can always just go to one of these repositories and see what's inside, right? There must be some sort of source code that the standard exists in and that it's written in. And a lot of times this will take form in the form of a BS file. So BS does not stand for bullshit. We're actually very serious people here. We're working on standards, right? We're working on the platform. So BS stands for bike shed, and it's basically this language that we kind of mix in with HTML and preprocess before we build a standard. It kind of helps us with cross-linking and some other fancy things. It's pretty easy to get the hang of. But you can check out the source there. All the standards exist at spec, or something.spec.whatwog.org. And basically, they look like this. They're the ones with the green logos that the browsers actually trust. And so we go in. Yeah, we can check out the standard, all kinds of stuff like that. And more importantly, if you're looking to get involved, you can go under the issues section here. And we have a bunch of different labels that we use. That's not where I'd want to go. So yeah, if we want to check out these issues, for example, this is the fetch standard, where things like the fetch method exist in the request object and stuff. We could go in and try to find the good first issues and be like, oh yeah, this is really cool, right? I can dig around here and maybe help out on some issues. And so now we're kind of on to evolving the web platform, right? We're working with a standards body to help fix some of the problems that they've identified in the platform. And so this kind of goes back to interfacing with the community and the community groups online. So I want to talk a little bit about this. When dealing with the What Working Group, there's a bunch of different ways to communicate with us. We're always on GitHub, of course. You can chime in on an issue and be like, hey, I really want to work on this. This looks really cool. I think it's interesting. We're always super, super happy to provide mentorship for people that are looking to get involved. Also, we're on the really big, bad, scary place that is IRC. We're in the Freenode, under Freenode on the What Working Group channel. I'm always logged in. A lot of the editors are always logged in. So we're always available to also help with questions and stuff like that. There's a lot of information here that I've thrown at you and things like that. And at the very end of the presentation, I'll kind of give you with one web page that you can go to kind of get a lot of this stuff from. But I want to talk about why to do this anyways, right? There's a lot of cool ways reasons to learn Angular and to learn React and to work on the web. But I think what's really cool is I know we're in Seattle and Microsoft land basically, but if you have a problem with some Windows APIs, basically you kind of have to work at Microsoft to get them fixed or changed or do something like that. But with the web platform, all this stuff is happening right in front of your face. It's all on GitHub. It's all free to participate, and anybody can do it and just go on and start working on stuff. And I think that's really, really cool. Web developers are in a really unique position of being able to influence and modify the platform that we all develop on every single day. And that's really exciting to me, and one of the reasons that I got involved. So I want to leave you with a repository that I just kind of started the other day. Now is the time to take pictures of the slides if you're interested in getting involved. There's a lot of information. There's a lot more information beyond just what I've covered in this talk. So check out the Cascadia.js repository that I maintain on GitHub. It's just kind of got some getting started information and some links to other talks that people have done on similar stuff and how to get involved in the web community and modify web standards and stuff like that. Finally, I want to leave you with some of the things that I've worked on to hopefully provide some motivation to show that you all can do the same. Recently, I've changed how fetch works, the fetch API. I've worked on Chrome to basically modify when we send credentials, when we make a request, stuff like that. It basically did the same for module scripts and took part in some of the standardization work for there. So that required, of course, talking to a bunch of the browsers and saying, hey, we're thinking about making this change. It kind of makes sense. What do you guys think? Can I do it? I also standardized and implemented the refer policy attribute. This is security privacy attribute in HTML. So I did this on the script element recently. So I like resource loading and security privacy kind of stuff. I've also implemented a bunch of console APIs. So the console standard I mentioned is a really, really good one to start getting involved with. So I encourage you to check it out. It's what I started with, and I also started working on Chrome partially as a result of that. Finally, I've been working on something called priority hints, which is just a new resource loading API that kind of lets developers tell the browser what priority they would like to be associated with a request. It's a new standard, and so we're digging through that. I did the implementation work in Chrome, and so we're just kind of doing some experimentation to see if it's going to be able to pull its own weight. But other than that, I hope I've left you with a good taste in your mouth when it comes to web standards, and I hope that you all feel motivated to get involved and contribute back to the platform. So thanks a lot. That's it.